Good night. So, the first topic we're gonna be speaking about, or the topic we're gonna be talking about today is 2.5 conjugate pairs. So, conjugate pairs are used to find a polynomial function of any degree with real coefficients. So let me rephrase that. So, when you're trying to apply conjugating pairs to find a polynomial function of any degree with real coefficients when given the zeros of a function. So what you have to do is, if this function has real coefficients and you have a plus bi as a zero of the function when b is not equal to 0, that means that the conjugate of a plus bi, which is a minus bi, is also a zero of the function. So to further explain that, we're going to solve the following example. We're going to find a fourth degree polynomial function f with real coefficients that has 1, -2, and 3i as zeros of the function, and f of -1, which is equal to 20. The first thing we're going to do, we're going to write f of x, function of x, is equal to, so the first zero we have is 1. So we're going to write x minus 1. We're going to multiply this times parentheses x, which is minus 2. So this is x plus 2. We got 3i, which is x plus 3i. And the conjugate of 3i, because like we mentioned, the conjugate of 3i when b is not equal to 0 is a zero of the function. So the conjugate of this is x minus 3i. We're going to divide this into two separate pairs. We're going to apply the FOIL method, or we can also know it as distributed property. We're going to apply the FOIL method to each set of pairs. We're going to start with the first one. We're going to do this, we're going to do that, we're going to do this. X times x, it's the same thing as saying x squared, x plus x times 2, is my mistake. X times 2, this is plus 2x. -1 times x, negative x. -1 times positive 2, -2. Close parentheses. X times x, x squared. Positive 3 times -3, -9. I times I squared. We have to remember that I squared is equal to -1. So here in the first parentheses and set of numbers, we're going to combine like terms. X squared, we're going to combine 2x minus x, which is the same thing as saying 2 minus 1. This is minus x minus 2, because this is the only number or constant we have. We got x squared minus 9 times -1. This is x squared minus x minus 2, x times x squared minus 9 times -1. This is the same thing as saying plus 9. We're going to do the same thing again. We're going to apply we're going to do FOIL here. X squared times x squared is x to the 4th power. So then we're going to have x squared times 9x squared. This is plus, because 2 minus 1 is 1. The next thing we're going to do is positive x, or times x squared. This is plus x to the 3rd power. X times 9, 9x, -2 times x squared, -2x squared, and -2 times 9. This is the same thing as saying -18. Then we're gonna combine like terms. X to the fourth power. We're gonna combine 9x squared minus 2x squared. This is plus 7x squared because 9 minus 2 is 7. But we made a small mistake here. The first thing we gotta do before we do this, we're gonna rewrite this in order accordingly to the degrees of each number and variable. So the first one is x to the fourth. The next one is plus x cubed, 9x squared minus 2x squared plus 7x squared plus 9x, because we got no other like terms for this 9x, minus 18, which is the only constant in this whole function of x. The next step we're gonna do is we're gonna write f of x, and one thing I forgot to mention is we have to write a outside of all this. What does a mean? So a is the leading coefficient, which is what scales the entire function. It controls how steep or stretched the graph is going to be. So we're going to write, so this is the function. Okay. The next step we're going to do, since we got this whole function right here, we also have f of -1 is equal to 20. We're going to write f of -1 is equal to 20. The -1, we're going to replace it for each and every x value of this whole function that we have here. So we're going to take, open a bracket, -1 to the fourth power plus -1 cubed plus 7 times -1 squared plus 9 times -1 minus 18. So the next step is just easy. We're going to solve all of this. -1 to the fourth power plus -1 to the third power plus 7 times -1 squared plus 9 times -1 minus 18. So this is all equal to -20. We got all this is equal to -20. So remember how I mentioned we have this letter a, which is going to be the leading coefficient for all this function right here. So we got f, or we can just simply write a of -20 is equal to 20 that we got from here, -20 that we got by solving all of this. What we're going to do next is divide both sides by -20. A is equal to -1. So the leading coefficient for this whole function right here is going to be -1. The last step we're going to do is we're going to write this all over again. Function of x. Remember I mentioned I'm going to rewrite this so it's easy for you to understand. Leading coefficient a times x to the fourth power plus x cubed plus 7x squared plus 9x minus 18. In this case, all we're doing is we're going to replace the leading coefficient -1 into a, which becomes f of x is equal to -1 times x to the fourth power plus x cubed plus 7x squared plus 9x minus 18. Then we're going to multiply this -1 times each and every one of these digits right here. Function of x is equal to -1 times x to the fourth power, -x to the fourth power. -1 times positive x to the cube power, -x cubed. -1 times 7x squared minus 7x squared. -1 times negative 9x, negative 9x, and negative 1 times negative 18 is simply positive 18. And then we have the function. We found the 4th degree polynomial function with real coefficients that has 1, negative 2, and 3i as zeros, and f1. The next topic we're going to be talking about is the rational zero test. What is the national zero test? This is a theorem or a method that is used to find all the possible roots or rational roots, or also known as zeros, of a polynomial equation with integer coefficients. To find the rational zeros, you have to divide all the factors of the constant term of a function to the factors of the leading coefficient. I'm going to go on to the next page. So the example we're going to be doing today to solve this is we're going to do the following. We're going to find all the rational zeros of f of x equals to 2x cubed plus x squared minus 13x plus 6. If we apply what we said, rational zeros, and then we take this equal to all the factors of the constant term, which is 6. What are all the factors of 6? We got all the integers, plus and minus 1. Yeah, we got plus and minus 1, plus and minus 2, plus and minus 3, and plus and minus 6. What are the factors of the leading coefficient, which in this case is 2? We only got plus and minus 1, plus and minus 2. We're going to take each and every one of this and divide it by this right here and this right here, which we end up with plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus a half, plus or minus 3 halves. 1 by 1 is 1. Then we got 2 by 1 is 2. 3 by 1 is 3. 6 by 1 is 6. Then we got 1 by 2 is plus or negative 1 half. Then we got 2 and 2 is equal to 1, but since we already have a 1, we don't write it. And we have 3 divided by 2 is plus or negative 3 over 2. 6 by 2 is 3, but we don't write it because we already have a 3. The next step is we can do a small table of values, x and y. We can try to plug in maybe 0, and then we can also plug in, we can try plugging in negative 5. We can do a small table of value in which if we apply this to this, we get 0, 0, 0, and then we get 6. Applying negative 5, replacing it for x, we got a total of negative 154. Another way we can actually solve this, instead of trying to do this whole table of values, is we can try to find which of this right here can equal to 0 when doing a synthetic division. In this case, we can take x minus 2 from here, and then we can divide it by that original function, 2x cubed plus x squared minus 13x plus 6. In order for us to do a synthetic division, whenever we have a negative number, it becomes positive. We take 2 2, we take all the leading coefficients, 1, negative 13, 6. The first term always comes down. 2 times 2 is 4. 1 plus 4 is 5. 5 times 2 is 10. Negative 13 plus 10 is negative 3. Negative 3 times 2 is 6. Negative 6. 6 minus 6 is 0. So we know for a fact that this is one solution. Just by knowing this, the next step is we're gonna factor this, because this technically this becomes the following: 2x squared, because this is the original function, and for each number that we go down 1 degree. 2x squared plus 5x, which is this right here, minus 3. The next step is we gotta factor 2x squared plus 5x minus 3. How do we factor this? We can factor this by grouping, where the product is going to be negative 6, 2 times negative 3, negative 6, and the sum is going to be 5. What are two numbers that when multiplied equal negative 6 and when added or subtracted equal 5? So those two numbers will be 6 and negative 1. And in order to factor this, we do the following: 2x squared, we can rewrite this again, plus 5x minus 3. We write this again, 2x squared, and then we write the two numbers that will multiply equal negative 6, and then the sum of those two numbers is going to be 5. Like I mentioned, those two numbers are 6 and 1, so we write plus 6x minus 1x minus 3. We group this and this. We can do it this way: 2x squared plus 6x. This is one group. The next group is negative x minus 3. We take the greatest common factor of all this, which we can take 2x. What do we multiply 2x by to get 2x squared? 2x. We multiply this by x. What do we multiply by 2x to get 6x? We get 3. In this case right here, how do we factor this? Take negative 1 times x, because we take negative 1 times x is negative x. And then we take plus 3, because negative 1 times 3 is equal to 3. Next, we group this: 2x minus 1, and then we group the common sets right here, x plus 3. So this is the way we factor this. The next step is we're going to write f of x is equal to, we're going to write x minus 2, this right here. Why? Because this is the 0 of this whole function. Since these are zeros of the function, we write 2x minus 1, then we write x plus 3. We gotta equal all this by 0. X minus 2 is equal to 0. This is x is equal to 2, 1. 2x minus 1 is equal to 0. Then we take this 2x is equal to 1, divided by 2, divided by 2, x is equal to 1 half. X plus 3 is equal to 0. X is equal to negative 3. So there we go. We found all the zeros.